Hello everyone. In this video we will try to understand a very interesting problem which is merge k sorted arrays. So let's understand the problem statement. Now the problem says that you have been given k arrays, right, up to k, which are sorted, right. All the arrays are sorted, all the k arrays are sorted, and you need to perform a merge operation on them. So after that you make a single array which is sorted, right. So the bird view looks like this, that you need to merge k arrays into one, and this all operation must be done in a sorted structure, right. So this is what the problem asks you to do it, right. Now one solution could basically would look like something, you just simply append all the arrays into the single one. You just append it again, you just append it again, and you append it and you make a single big array, right. Without considering the sorting of it, and then you did the sorting, right. So anyhow then you return it, then you will say that okay, the I also merge all the arrays, and the array is sorted, right. So you fulfill the conditions, right. But this solution will again take a lot of time, right. And it will not be advised. The interview will basically ask you to optimize the approach, right. So what you can think of. So in my previous videos I have explained that what are the identifications element for heap, right. So one identification is would be sorting, right. So you will clearly understand that by sorting it, the solution is there to help us out, right. By sorting we can solve our problem. Second identification element would be k, like the k keyword is given to us, then we can try to think of a heap approach, right. I'm not saying the 100% if anywhere is k is given then you should directly jump to heap. There might be some better solution exist without using heap, but I'm just saying that this could be one of the identification element. And third one is would be toppest or smallest or something else would be given to us, then we can try to think of it, right. So in this problem I can see that two identification element is appearing, right. So it's really right time to think of heap. Fine. I will say okay, I'll think of an heap data structure, but which heap? Min heap or max heap? Right. So we need to make we need to make an a single array which contains the smallest element first and then largest element in the last, right. So if you will start from the left, then I should probably must be using min heap, because I would be needing the smallest element first and then the next smallest element first and then next smallest. If I'll start from left, then I would be needing max heap, and you would probably know the answer why, because I need the maximum element first, then next, and then next, and then so on, right. So for the sake of simplicity I will be going with the min heap. You can also try this problem with max heap, but I'm just, for time being and all, I'm just thinking the problem to solve using min heap, right. So okay, great. So no, we understood that this problem, and we are convinced that we should use heap to solve this problem. But okay, how? So let's move to the problem statement. This is available in Geeks for Geeks, right? So what you can do? You can use min heap. What else? So let's try to understand it. If you just simply think of a min heap container, then what you will say that okay, I'll just store the I will get the minimum element from the top, right. So if I'll store 1, 4 and 7, all the initial elements, right, 1, 4 and 7, so it would come up like this. I've just stored the initial of every array. I have stored the initial, or the first, or the zeroth index uh, into the priority queue, right. Then you will say that okay, you are storing the actual elements, so the smallest element would come up, right. Smallest element would come up. So that is great. I get the smallest element, and this is the first element in my array. But what about the next, right? Because I cannot just simply take the 4, because in the starting it's okay that we can consider 1, because all these arrays are already sorted, right. It is mentioned in the problem that we have been given k sorted arrays. It is given to us, so I can consider 1, which is the first element. But what else after that? So I cannot go other than, 1. So we need to store something else as well over here along with the data, right? Along with the actual data, we need to store something else, so that I know that, okay, if this is the smallest element, then after that, for the same array, the array, like from the which array it came, and by which pointer, by which index it came, by which array and by which index. So we need to store these information, and after that, by extracting it out, we can store the next element for this array and the next element for the array itself, right? For an example, don't get confused, if you are till now. So let's take this example as well, right? So we just store 1, 4 and 5, 1, 4 and 7, sorry, right, in my min heap. So you will say, okay, 1 is the smallest element and I got it, but what about it? I cannot simply take 4 or 7 out of these. So I will say that, okay, I will be storing that it came from 0 index array. This is the 0th index array, this is the first index array, and this is the second index array, right? But okay, you stored which, from which array it came, but by which pointer, right? You also need to store the pointer or the index to be specific, right? Like you took the first, you took the 0th array, but at which index it appear, right? So if 1 is at the 0th one, then probably I would not gonna store 1 again. I need the next one, or index plus 1th, right? And I hope now you are started getting the problem statement and solution as well, that okay, we need to store the again, and then the smallest element will come up, and then I'll store the next one, which is 2, and 2 will come up, and again, and so on, until all the elements of the array or all the elements of particular index goes out of bounds. Then I'll just simply pop it out, right? So that's how it goes, and you will understand more when we will write the code, right? So okay, fine, you will say that, okay, I understood the approach. So what else, how should we start writing it? So you can simply first write the priority queue, right, the min heap. But by storing all the three data structure, right? What are the three data structure? We would be needing tuple, right? One is the data, another one is the arrayth, like which array is there. I'm using C++, don't get confused. I'm just giving you the information, like what are the data points which will be needed. And another one is the index, like what is the index for that element, right? And to define all these three in the priority queue, it will be it will not that complex in logic, but it will be difficult to write. So what I'll do is I'll define the type definition, and I'll store all the three data points in the vector, and I'm naming it as type, right? So now it will be easier for me to write the priority queue, and I'll just simply say type vector of type and greater, because I would be needing the small element priority before, right? Okay, fine. What else? We have defined the priority queue. Great. So as I said, initially I'll be storing the 0th pointer for every array, right? And how many arrays we have? We have k arrays, right? So I'm starting my for loop from 0 till k, because we have the k arrays. And then what I'll be doing, I'll be storing all the initial or the 0th index element along with its pointer and its array in my priority queue, right? So this is array, and ith one is basically take me out that, okay, which array, or like which array am I using. After that, I would be needing the 0th one, because I need the first index, or I mean 0th index of every array, right? After that, I can store that which array it came from, so I can store I, and after that 0th index, right? 0, we already know that why we are using it, right? So then I will be, I just need to, before iterating it, I just need the answer vector and then return it, right? Great, but my answer vector is empty. So what I should use? I should start iterating it and store it in answer first, right? Then after that we will return it. So I cannot return it empty, it will say wrong. So I'll say, okay, I'll extract out the top element, and I will say pop. I write these both sentence together because I believe I understood that I also extract it and I also popped it, right? So it's easier for me to get. And by now I understand that the top element which I got should be the minimum one among all, right? Because I'm using it in my priority queue. So, and I know I'm storing it in my zeroth index. And also after that, just storing one in my answer doesn't satisfy all, because I also need to track for my small two little cutie, right? So I need to get which array it came from, right? So that is stored in the index 1. As I said, I store in the index 1, and then integer j, which is present at the 2, right? It says what? It says index. What is the current index for that, right? So okay, you will say, okay, so no, push it and store the array ith and j plus 1th, right? You will say that, okay, store the next element and store its array, like what array it came from, and you can also store the j plus 1, right? And here we go, right? You will say that. Now I'll say no, you should not, the solution is not complete, because you need to consider end case as well, right? Because you are storing the next pointer or next index, but how would you know that this next index is not out of the bound, right? So that's the point. We need to check that, if okay, if j is equals to array of I dot size minus 1, if this is the last one, then why you should need to store it, right? And now the solution is complete, right? I hope you get it. Let's try to compile and run it. I hope everything is fine. I'm not sure. Fine, great. And then I'll try to submit it, and then boom, great. I know this will work. So that's how it goes, and that's all what I wanted to say about this problem. And other than that, I also need to say one thing which I know about this problem statement, what its application, right? So one application that I know about this merge case order is external sorting. Now what is external sorting? Now let's say you have been very big log file that cannot store in cache, right? And you need to sort it. Right? So what you can do, right? What you can do, people gonna ask you in other interviews that how you can sort the array which is not fitted in the cache. So what you can do is, what you can say that you can just made the log files into several chunks, right? You made the log files into several chunks. Let's assume that you have made k chunks, right? And this individual chunks is capable of sorting inside the cache, right? And after that, after that you should know what we should do, right? The problem is simple, and it applies to merge case sorted arrays. So that is one of the interesting application which we can, or which any interviewer can ask to you, like where are its application and how we could use it. So I hope, like after that, like just you need to merge, you need to apply case sorted arrays, and your problem will be solved. So that's all for this video. I hope I have added some small value to it, right? Small. So yeah, thank you so much for watching. I hope you will have a great day. Bye.